So the Wojtek is the associate director at the Monash University E-Research Center, and he's a project director of the massive National High Performance Computing Facility for Imaging and Data Sciences, and also project director of the ACCS, the Australian Characterization Commons at Scale, which deployed national scale digital infrastructure for computational imaging. So yeah, he is an expert in developing and delivering the digital scientific infrastructure, and so his specializations are high performance computing, data processing, image processing, and neuroinformatics, and as well as cryo electron microscopy data pipeline. So and also that he is one of the core member of the image data working group of the Global BioImaging. So he contributed very much to this working group. So I would like to appreciate his contribution. So, and yeah, he is, I hope he will give us input from the bioimage data infrastructure or computational bioanalysis perspective. So, and yeah, I hope we can get it. So yeah, please, Wojtek, if you are okay, so please start.
Yeah, thanks so much, Shoichi. Can you see my slides and hear me okay?
Can hear you, but cannot see your slide so far.
Cannot see my slides. I'm sorry. I've been trying to share them this time. One sec. I'm sorry for that. Let me try again, please.
Yeah.
Sorry about this.
Yes. So, but it's not the presentation mode.
Just give it a second.
Yeah. Great.
Is that okay?
Perfect. Perfect. Yeah.
Okay. Thank you very much. Thank you so much, Shoichi. Really appreciate the introduction. So I'm here to talk about the Australian Characterization Commons at scale. There are a few of us who are involved in this project here. I'll shout them out at the end of the presentation. This project is funded by the Australian Research Data Commons, the ARDC, which is a national government infrastructure initiative to fund e-research and cyber infrastructure. It involves quite a number of universities across Australia. Before I talk about the project in detail, I do want to just give a little bit of context about some of the things that we did as background to the project, because I think they are really important to talk about why we're delivering the type of activities that we are delivering. Over the last few years, the Australian imaging community and characterization in Australia has a certain name because it's a number. It used to be a number of facilities in Australia, a number of infrastructure facilities, but largely we're talking about various different types of imaging, both microscopy and human and other capabilities as well. We have been working together for quite a while, and we have, I think, successfully identified many of the challenges that we're facing as a community. And those challenges include scale and complexity. Just basically the data is getting bigger, and so therefore the science is literally being affected by the compute. The second is that fundamentally working with digital objects is hard, and it remains hard, and really the only solution there is fair and to provide some of the glue to make working with digital objects easier. And also that expertise is really still rare in this space, because we're talking about the overlap of expertise between imaging and informatics. So we've been putting together this strategy for a long time in Australia for a number of years now around well, a national infrastructure program to address the fact that to address scale, a program to make characterization digital objects more fair, to address the fact that working with digital objects is challenging, and also a national program to spread knowledge and underpin change. And in many ways, a lot of these aspects that we've been planning have now eventuated into the program that's called the Australian Characterization Commons of Scale. We also did a lot of work to understand characterization instruments, so to understand the imaging instruments that many of the facilities that are participating in this project actually run and support. Last year, we ran a fairly large survey of characterization facilities. We identified now, and this is a little bit old, this data, but well over 400 instruments. We got good responses from well over 100. And what this really did is give us the evidence to propose this project. So just across the instruments that we were successfully engaged with, that we were able to collect data on, we understood that around about 25 petabytes of data are collected a year across these instruments, which is, you know, more than any one particular university can handle. It's a significant amount of data. We're also able to understand these sort of key characteristics that I think are really effective to communicate to funders, such as that on average users require between half a year to 1 year of processing time to extract the knowledge that they need out of their data. I think that's actually really interesting information for research funders. We also ran a symposium last year, and I really want to highlight this because it did include some of the participants here through Global BioImaging. So Jason Svendlo in particular, Claire Brown, both presented at that. And that was really important to us to ensure that, well, it's an event to get everybody together, to get everybody on the same page, but it's also an opportunity to get international perspectives and also to demonstrate to our funding partner that we do have the support of absolutely the world's best. And I think Global BioImaging has been really important to help us organise this aspect of it in particular. So the actual project itself is around about 2.5 to 3 years of funding. It includes 10 universities that have contributed in some way. 3 NCRIS facilities. Paula defined NCRIS yesterday. NCRIS is our infrastructure funding model in Australia. And what we're really doing is this, that we're developing a coherent and accessible informatics landscape that promotes collaboration, increases return on investment, and delivers value to researchers. The concrete aspect of what we're delivering is what we call a characterization commons, which is really an ecosystem. It's not one thing, it's an ecosystem of computing services, systems, data repositories, workflows and services, all connected to instruments. And we have 3 specialized programs under that, and they're in big data EM and correlative techniques, in biomedical imaging collections, and national tools for scattering and beyond. And I'll focus on 2 of them a little bit today because I think they'll be the most of interest to this audience, the first 2. So what are we doing in practice? Well, we're deploying tools and services across 4 nodes. And I'll show you a little bit about how we're doing that. We're both deploying a federated desktop environment across nodes and also web-based tools. As things move more cloud native, which is certainly something that we're seeing, we're going to put more and more focus on cloud native applications. We're doing a lot of work on interoperability, integrating flagship instruments, building community. We have a dedicated training program, and building sustainability through direct engagement with the institutions as well. And then we're doing this in a number of different ways. One thing that I will talk about today is the way that we're using sort of continuous integration, continuous deployment as a mechanism to try to make this all easier to manage, because what we're undertaking here is quite large. So that's certainly something that I'll try to identify and talk about. One thing that I do really want to highlight is that this is a very distributed project. And it involves, this is the organizations that are involved. There's many of them, And the people that are delivering to the projects are across 5-6 sites across Australia, and Australia is fairly large. None of these are sites that you can easily travel to by car. These are all a flight away. So I kind of want to highlight this because I think it's of interest to this audience here. This is a challenge for us. Each of these participants, each of these institutions are all different, and they all have different strategies, and they all have different challenges, and they all have different opportunities. And this is something that you know, it's both a challenge and an opportunity for us. We wanted to address this right out from the start with the project. And so, you know, on the one hand, we could try to force everybody down the left-hand side of this slide here, which is a centralized management sort of structure, single user ID across everything, single technical operating model, single operating model. The problem with that is that I don't think we would be able to cater to local advantages. We wouldn't be able to perhaps tailor for local challenges as well. And I don't think we would have been able to hand over sustainably as well. On the other hand, we could do distributed and heterogeneous everything across every single site. And then we don't really get the benefit of working together. So, you know, what we've tried to do with this project is develop a shared approach, which is a single user ID where possible, a signal technical model where possible, strong documentation and accessibility, providing users with a strong single front face, but really under the bonnet, we are a collection of things, a collection of capabilities across Australia. And I do think that that's quite important and essential to what we're doing. This is the project itself. And I appreciate this slide's a little bit difficult to sort of get your head around. This is the slide that we used in the proposal itself. So I'm just going to take out a bit and sort of just focus on this center bit for now and just say, look, this is what we're developing. It's called the Characterization Commons. It consists of hundreds of POSIX applications, so applications that run on Linux, because that's the majority of the applications that our researchers use still now, though cloud native, web native is becoming more common. And we're trying to address those as well. We're addressing data collections and data repositories as a key outcome of the project as well. And one of the major things that I really want to highlight is we're addressing the artifacts, the code of the project as a major sort of first order outcome of the project as well. So a code repository, common container repository is also really important to us. There's a number of work packages and I won't dwell on them, but I'm just going to go through a couple of the relevant ones. There's an infrastructure package and I'll talk about that now. One of the things that we're doing is we're deploying a federated interactive desktop across 4 nodes in Australia. Those 4 nodes are Melbourne, Brisbane, Perth, and Sydney. You can see me loading up a video here of that interactive desktop. I produced this a few minutes before the presentation. It's a little bit clunky, but you can see that it already supports hundreds, in fact, of tools that we can deploy quite easily and really provide to anybody in Australia with just a few, button clicks really to get access to it. This environment is something that runs at one location really in earnest at the moment. We have nearly 100 concurrent users a day and well over 600 users so far. We're now in a sort of production capacity in both Brisbane and Perth. In Brisbane, we just ran quite a large workshop with 20 participants off one instance. In Perth, we're limited by hardware, but we're going to scale. And then we're planning a deployment in Sydney as well in the future. One of the things that I really want to highlight that was part of a proposal and an important part of our proposal is that we are making the fundamental argument that over time we can make it more efficient to run these things. And we're going to be adopting, effective DevOps practices that are used across, corporations such as Google to run really large fleets of things. And so continuous integration, continuous deployment is one of these things that we're going to apply. And it's really a principle that says, well, you know, you have this Git repository where you keep your source code, you do effective testing, you submit your changes to Git, and you push out as long as it passes the tests. And that's it. And you continue to upgrade what you push out. And look, this is something that we're going to see how all of this goes, but it was a fundamental part of our proposal. I want to talk about a number of specific parts, and the first is the big data producing EM component of the project. And I'm going to focus on cryo-electron microscopy. It's certainly the area that I know the most about, and is certainly one of the early focuses of the project. This is a very simplified workflow for cryo-EM. Anybody here who knows cryo-EM totally understands that it's not quite this simple. It's nowhere near, but let me just use this as a way of unpicking things. We at the moment, and we are in our bootstrapping phase still now of this project, but at the moment what we're doing is we're talking to a lot of cryo-EM facilities and understanding the challenges in this workflow. And, you know, the simple fact that some of these data sets are, you know, anything up to 10 terabytes or beyond is a major challenge. The fact that we're not necessarily capturing experiment or sample preparation level metadata earlier on is also another challenge. The compute capacity for cryo-electron microscopy remains a significant challenge. And so these are some of the things that we're wanting to address through this project. This is a diagram of the way that we do cryo-electron microscopy at the facility that I run, which is a high-performance computing facility called Massive, specifically for data. We focus almost entirely on data. And it already starts to unpick some of the complex data engineering that we have to do to make cryo-EM work for 5 microscopes across Australia. There's a significant amount of data infrastructure, you know, the engineering that you really need to handle the data coming off those microscopes. If you follow one data set along, it goes through a whole lot of states on your system, from end to end, from capture to publication. And we did this sort of analysis a little while ago to kind of try to understand how we're actually underpinning our users. Because me as a facility that provides the compute, I actually don't have the capacity to continue accepting data. I need to continue moving data off the system in order to continue accepting new data. And so what we do is we have data move through a bit of a workflow, a process, you know, a series of state changes. As the data gets older, it can perhaps be moved off. It gets processed, that means that we need some new metadata. When it gets deleted, that also means something. We've done these sort of maps of how data moves across our systems because we actually think that we can start to automate a lot of this. And the prime example of the folks who do this are the physicists. So the large, you know, data sets that come off CERN, or, you know, some of the detectors there, LHC perhaps, they do move through these sort of workflows and these state changes as they go along. And so we're going to be looking at adopting some of these to try to track how to try to control how large electron microscopy data moves through the system as it gets processed by users. And of course, it has to be interactive as it goes. And another focus area of the project is biomedical imaging collections. And let me just talk about that very briefly. I am running out of time. I'm mindful of that. We have a whole focus here across 2 institutions, and the focus isn't just on collections. Lots of people are doing collections, and we're doing collections, and that's great. And lots of people are doing analysis, and that's also terrific. What we really want to do here is to provide a single stop shop for processing data collections. So that means we provide these collections, and we also provide the analysis environment to do everything that you might need to do to that collection. So if a user comes to me and gains access to my system through a merit allocation scheme, they might actually say, well, I'm not here to capture my own data. I'm not here to do my own data. I want access to this collection, and I want access to it for the next 2 years. And that's why I'm here. I'm really here to process this collection in anger. And so how do we begin to provide that comprehensive environment for taking a collection and providing everything around it that you might need to process? One of the early things that we're doing is we're actually looking at the IDR as an early exemplar here. We have users who want access to IDR data. They want interactive access to IDR data in the same way that we saw in the first presentation. They want it streamed, and they can't do that from Europe. And so we're already starting to create, perhaps in time, a mirror of IDR in Australia. That might be the longer term goal here. There's a number of data collection management consideration and challenges to all of this. We've produced a discussion paper, a very early discussion paper about some of this. I won't go into this in detail. I'm sure you know many of the challenges here that are identified. Finally, we really, and I think this is still something that in our part of the proposal is under-resourced. We do need to have a really good, strong aspect towards open standards, APIs, and metadata. This is some earlier work from Andrew Mennett, who's here today, who did lead a project last year called Bringing Long-Tail Microscopy, which kind of began to address many of these challenges around, well, what's the state of metadata, microscopy metadata across Australian facilities, and how can we improve that over time? As a response to some of this, we will be looking at how facilities manage their metadata at the point of generation. What is the single common elements of metadata that we might want across our microscopy facilities in Australia? My absolute last slide, and that is just to sort of, and I really want feedback on this actually, because I think this is the cohort that could provide us really strong feedback. We are right at the start of our journey. So the project that I'm describing was funded at the end of last year. We have just gone through bootstrapping, really. We now have a lot of our staff on board, but we're still very early days. The question is, how do we measure success in this project? We did put up a value proposition in the proposal itself, and this is the summary of the value proposition. So this is what we'll be going to look back on the project and go, well, at the 1 year mark, 2 year mark, 3 year mark, has it been a success? But I do want to open this up to this group here, and please tell me if there's things that you think we should be measuring, and ways of measuring large infrastructure projects like this for success. I do want to acknowledge quite a few people over on the left-hand side of the staff that are formally engaged on the project itself. As I said, as of very recently, because we are really just kicking off. But there are also here today quite a lot of CIs on the proposal. I haven't listed all the CIs because there's about 40 of them, but the ones that I've certainly noticed in attending today are Lisa, Graham, Paula, Andrew, Ryan, David, and David as well. Thank you.
Thank you very much. So, and thank you very much for another thoughtful and comprehensive talk. So, and very much so good input. So I want to have some question, comment, and maybe Ken. So you have a question, so please show up.
Yeah. Thank you very much for the talk. It's quite interesting, especially on the part that you mentioned about moving data. You need to move the data all the time on the site Cryo EM slide. I was just wondering about the bandwidth as well, the flow rate. How I mean, we find it quite. I mean, it's quite stressful on moving data around actually. And
absolutely.
Also about you mentioned about discussing about the versioning, but also about validation. After you move the data, how do you know whether the data is haven't changed and things like that?
Well, exactly, and that's a state change. If it does change, it's a state change, and something then needs to happen. I mean, you know, you can. There are systems that can manage this, but we don't typically use them in this field. So with regards to bandwidth, that's a problem, but it's also there. I think there are solutions to it. I find that obviously, so we support cryo electron microscopes both locally on campus, and we also support them off campus. In fact, 1,000 kilometers away, they do the bulk of their processing at Massive from the University of Wollongong to Monash University. So this can be done, but the solution needs to be tuning of networks, and that's an end-to-end problem, and it's very difficult. But also, secondly, reliability, and I mean, a data mover that restarts. Yes. And that's such a simple thing. That is such a simple thing, but just giving somebody the confidence to know that, okay, they can go and get a cup of coffee and the data's going to be there in an hour or two, and they don't have to keep checking it.
Yes.
Now some of this, it is a full stack, and actually, unfortunately, it is an end-to-end problem, and the last mile is typically the most difficult.
Okay. So do you have any, how do you say, solution, or do you have a really kind of good workflow in order to achieve that? I mean, we found that it's probably quite, how do you say it, not very sustainable. I mean, we can do a few, but not all the time, so to speak.
Ken, you're identifying the project. I mean, they're quite genuine. No, that is a part of the project, and we're working on that right now. And so there are solutions to this where where you can have very, very reliable data transfers, and we're starting to deploy some of those in Australia. These are file transfer services as opposed to just somebody providing you with a network. So we're starting to leverage some of these services, but then over the top of that, we want to go another layer and effectively put a workflow or data orchestration layer over the top of that. And that will allow us that state change management that you saw in the other slide, which, okay, so, where is the data right now? And is it also archived, right? And is it also backed up? If it's backed up, I can delete this other copy that I have on my local PC. These sort of higher level information about what's actually going on when the data moves through this process. And that's not there. That's what we're going to be trying.
Okay, thank you.
Okay, so another question from the Katarina. So can you show up, Katarina? No?
Yeah, hi.
Oh, yeah.
Yes, there were many other questions before me. So anyway, I'm curious to hear more about this federated desktop concept you mentioned. Could you tell us a little bit more about that?
Yeah, absolutely. It's the Australian Characterization Commons is a project that has largely it's the next extension of a project that we've been running for a number of years called the Characterization Virtual Laboratory. You'll have seen the acronym in the presentation, the CVL. And since about 2012, we've been developing this online desktop environment, which is effective purely because it has hundreds of tools in it. It's a single-stop shop where any researcher can go, and Fiji and ImageJ and all of its 10 versions are there and available, and configured well for you. Secondly, I can provide good hardware, right? So it runs on high-end GPUs. It also runs on very low-end GPUs as well, because, you know, I want to provide the full gamut. There are some users that don't need the high-end hardware. They'll happily just use the low-end hardware. And at most of the sites that we're deploying, not all, at most of the sites that we're deploying, we're trying to integrate with high-performance computing. So the original version of this runs on the massive high-performance computer, as in massive, sorry, is the project name, not, it's called Massive M3. It runs along that side, that HPC system, and it's a gateway to that HPC system. So Cryo Electron microscopy users, in particular neuroimaging users, they'll come in, they'll learn how to use those tools in that desktop environment. And then when they approach us for that second conversation, which is along the lines of, well, I've actually got 200 brains rather than just one, we'll teach them how to do the next steps, which is progress to the HPC systems. But their data will already be there, right? We've already jumped through a lot of hurdles. So that's the overview. I'm happy to provide more information about that.
Okay, so we are mostly running out of time, so maybe it's going to be the one quick question from the Perrin from France, but he's not, his microphone is not working. So can you give an idea of the number and the time of the people involved in, for example, the Australian IDR meter or their profile? So this, can you give us a brief comment on that?
The overall project or a specific part? Sorry, I misunderstood that, I think.
Maybe the Australian IDR meter, for example. So how
okay,
much
well, we don't know. We haven't done that yet.
Okay.
we genuinely don't know. I tell you, and I have talked to Jason and others about this, and Josh. What we would love is to have the data sets that we know Australians care about. It's not going to be everything. But what we would love is to have a local mirror of the data sets that Australians, you know, we know are likely to be used. And they're usually the ones that Australians have uploaded themselves, or, you know, the 10% most popular. And, you know, it would be great if there was a mechanism where we could keep that as a mirror. But I do not know how much work that is. And part of the project is working out whether that's going to be a focus for us.
Okay, thank you very much. So, and there are many questions remaining, but so in that time, so I want to stop here. So I would like to thank the Wojtek for beautiful and thoughtful presentation. Thank you very much.